here A and B are called the vertex of the ellipse. So vertex means it is the end points of an ellipse on the major axis. The general equation is A square is equal to B square plus C square. Since we are supposed to calculate C square here, so if we alter this relation, we will get C is equal to root of A square minus B square. And when you observe the foci, 0, plus or minus 5 is a coordinate on the y-axis. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Department of Mathematics. Today in this session, we are going to study about the another part of conic, that is an ellipse. So we have seen when a plane is intersected with the inverted cone naps, we'll get an ellipse with under different condition. That is when alpha is less than beta and less than 90 degree. When both inside angles alpha and beta are less than 90 degree, we'll get a curve called ellipse. Now, what do you mean by ellipse? So you can see here for an ellipse, we have two focus here. These two are called as focus. So its ellipse is a set of all points whose sum of the distances to any point on the curve ellipse. Suppose if I consider this point as P1, so the distance F1 plus distance F2 is same as to any point P2, P3. If you add focus F1, P2, F2, P2 will be the same. So that means, so the set of all points in a plane, the sum of whose distance from two fixed point is called an ellipse. And that two fixed point is called as the focus of an ellipse. So as a circle, we have one center which is equidistant to any point on the circle. But here it is not called as center, they are called as focus. So this is a set of all points whose sum of a distance to any point on the ellipse will be same. So from the figure here, P1 F1 plus P1 F2. So the distance P1 F1 plus P1 F2 will be same as P2 F1, P2 F2. The distance will be same. Maybe the distance may decrease and this is the maximum length here. So when you take any point, suppose if you take a point here, the distance from focus F2 is less, whereas the distance from focus F1 is more. But the total distance will be same. So when you collect all those points, we'll get a curve called ellipse. So now there are some special characteristics of an ellipse here. So I have taken a line here. So this line, we can take it as an x-axis. And this line we can take it along an y-axis. So here the line joining the center as well as the focus. So this is called as the major axis. So this is the focus. This is the center of an ellipse. So x-axis and y-axis. So the line joining the center whose distances from focus F1 and F2 will be the same. So the distance from the center to F2, center to F1 will be the same. That's why this is called as the center. Usually here we consider the origin as a center, a 0, 0. We'll take origin as a center between the focus and the ends of the ellipse along the major axis. These points are called as vertices. So the points are called as vertices and the ends of the curve along y-axis here will give you the distance. So this axis is called as the minor axis. So the line joining the center and the focus of an ellipse whose end points are called as the vertices and this line is called as the major axis, and any line perpendicular to the major axis again passing through the center is called as the minor axis. Here we have taken y-axis as a minor axis. And also the distance of the focus to center will be same and it is considered as C. So it is called as C. And the distance from the center to the vertex. So the end points on the major axis are called as vertex. So if I name it as A, B, so here A and B are called the vertex of the ellipse. So vertex means it is the end points of an ellipse on the major axis. So therefore, the distance from the center to vertex will be same. So A. So the total distance will be 2A, but the center to any vertex, the distance is always A. Suppose if I consider B as a vertex, then the coordinates of B can be taken as a comma 0, whereas this will be minus a comma 0. The distance is a, but the coordinate is minus a. Next, we have a minor axis. So, along the minor axis, the end point of the ellipse from the center, the distance is considered as B. So, therefore, if I consider this as C and D, then this coordinate can be written as 0 comma B, whereas this can be written as 0 comma minus B. B is the distance, but 0 comma B is a coordinate and 0 comma minus B is the coordinate of the end points on the minor axis. So, hence we can consider here. So, the midpoint of the line joining the two focus are called the center of the ellipse. The line passing through the center as well as the focus of the ellipse is called as the major axis, and any line perpendicular to the major axis and passing through the center is called as the minor axis. The end points of the ellipse on the major axis are called as vertex, and the end points of the ellipse is also along the minor axis. So, the vertices can be written in the form of plus or minus a comma 0, because the distance of any vertex from the center is a. So, we have two vertex, that is a comma 0 and minus a comma 0. Hence, vertex or vertices of an ellipse can be written in the form of plus or minus a comma 0. Next, the focus or foci can be written as plus or minus c comma 0, because the distance of a foci from the center is c. So, we have one on the positive side, the other on the negative side. Thus, the foci is plus or minus c comma 0. And length of major axis. So, length of major axis is just 2a. So, from here to here, this is the length of major axis, and length of minor axis is 2b. We have a term called eccentricity. Eccentricity is used to find the geometry of the curve. So, eccentricity is always given by c by a. In an ellipse, it is always less than 1. Eccentricity of a curve is less than 1 means which is an ellipse. So, for an ellipse, E is always less than 1. Next, distance between foci is 2c. So, these are the major things we need to remember when we look at an ellipse. So, now we have a relation between A, B, C, that is the relation between the semi-major, because it's a major axis here. So, semi-major means half of the length. Similarly, semi-minor again half of the length, and we have here C, that is the distance between the foci. Hence, we have a relation between the semi-major, semi-minor and the distance of the focus from the ellipse, and that is given by A square is equal to B square plus C square, or we can write here C square is equal to A square minus B square, or C can also be written as root of A square minus B square. So, this is the relation between the semi-major, semi-minor and the distance of a foci from the center of an ellipse. So, I have told you about an eccentricity. So, the eccentricity of an ellipse is the ratio of the distance from the center to one of the foci and to one of the vertices of an ellipse. So, C is the distance between one of the foci with respect to the center, and A is the distance between one of the vertices from the center. So, therefore, it is the ratio of C by A, and eccentricity of an ellipse is always less than 1 because you can see A is always greater than C here. A is always greater than C. That is, the distance between the center and the vertex is always greater than the center and the foci. So, therefore, in a ratio C by A, it has to be less than 1. Next, we have the standard equations of an ellipse. So, we have here formation of ellipse in two ways. So, one is we have an ellipse, horizontal ellipse here. So here the major axis lies on x-axis, whereas here you can see the major axis lies along the y-axis. So thus the standard equation of an ellipse of this form is given by x square by a square plus y square by b square is equal to 1. Whereas here the equation is x square by b square. This is b here. So along x we have a b square and y square by a square is equal to 1. Remember, the value of a is always greater than b in both the condition. So here the focus lies along the x-axis. So therefore the coordinates are c, 0 minus c, 0. Whereas here the focus lies along y-axis. So therefore it is 0, c, 0, minus c. And when you talk about vertices, here it takes the form of a, 0. And here it will be minus a, 0. Whereas here if you talk about the vertices, here it is 0, a. And here we can write it as 0, minus a. So depending upon the major axis lies along the coordinate axis. So if major axis lies along x-axis, then we have an horizontal ellipse. If the major axis lies along the y-axis, then we have a vertical ellipse. Next we have a latus rectum. We have already learnt the latus rectum is a line which passes through the focus and perpendicular to the axis. So here we have two focus and hence we have two latus rectum for an ellipse here. So it's a line segment passing through the foci F1 and F2 whose end points lie on the ellipse. So the end points will lie on the ellipse. So these are the end points of a latus rectum, and the length of the latus rectum in an ellipse is calculated using the formula 2b square by a, where b is the length of semi-minor axis and a is the length of semi-major axis. So now by observing all these properties, we are supposed to calculate here or find the coordinates of foci, vertices, length of major axis, length of minor axis, the eccentricity and the latus rectum of the ellipse. So the first question is x square by 25 plus y square by 9 is equal to 1. So this is a standard equation of the form x square by a square plus y square by b square is equal to 1. So from this we have a square is equal to 25. That implies a is equal to 5. B square is equal to 9. That implies b is equal to 3. Now the first is we are supposed to find the coordinate of foci. So foci for this type of ellipse is plus or minus c, 0. But we don't have c here. We have a relation between the semi-major, semi-minor and the distance of a foci from the center. So which is given by c is equal to root of a square minus b square. The general equation is a square is equal to b square plus c square. Since we are supposed to calculate c square here, so if we alter this relation, we will get c is equal to root of a square minus b square. So c is equal to a square is 25, b square is 9. So 25 minus 9. So we will get root 16. So the value of c is equal to 4. So therefore, the foci for this ellipse is plus or minus 4, 0. Next, we are supposed to write the vertices. So vertices is plus or minus a, 0. So therefore, this becomes plus or minus 5, 0. Next, we have length of major axis. So length of major axis is 2 times a. So therefore, 2 into 5, 10. Next, we have length of minor axis. So length of minor axis is 2 times b, which is 2 into 3, 6. Next, we are supposed to calculate the eccentricity. Eccentricity is E is equal to C by A, which is 4 divided by 5. The last one is the length of latus rectum. So which is given by 2b square by A, which is 2 into 9 divided by 5. So 18 by 5. So these are the physical terms for an ellipse. Next one, we have 9x square plus 4y square is equal to 36. So first let us reduce this in the standard form. We'll divide the entire equation by 36 because we need 1 on the right hand side. So if we divide this by 36, then we will get here x square by 9 by 36 becomes 4. 9 4s are 36. 4 y square divided by 4 by 36 become 9 is equal to 1. Now here you can see the denominator value of x square is less than y square. So therefore this is the standard equation of the form x square by b square plus y square by a square is equal to 1. So this is a vertical ellipse. When you look at the standard equation here, the horizontal ellipse will have a square, that is the denominator value of a square under x square will be greater. But when you look at the vertical ellipse here, the denominator value of x square will be less than y square. So here always remember a is greater than b, but depending upon whether a square lies below the x square or below the y square, you can observe the horizontal and vertical ellipse. Now we have this form because the denominator value of x square is less than y square. So therefore this becomes a square and this becomes b square. So wherever you have the maximum value, that will be considered as a square, the other will be b square. Now a square is equal to 9, which implies a is equal to 3. B square is equal to 4, which implies b is equal to 2. So c can be taken as root of a square minus b square, which is root of 9 minus 4. Therefore, the value of c is root 5. Now, let us write the properties. First one is the foci. Since it is a vertical ellipse, the foci takes the value of 0, plus or minus c. So, therefore, this is 0, plus or minus root 5. Next, we have vertices. So, vertices is along y-axis. So, therefore, it is 0, plus or minus a, which is 0, plus or minus 3. Next, we need to find out the major axis. So, major axis is 2a. So, therefore, the value of a is 3. So, 2 3s are 6. Next, we have minor axis. Minor axis is 2b. So, 2 2s are 4. Next, we have eccentricity c by a, which becomes root 5 by 3. Next, we have length of latus rectum. So, which is 2b square by a is equal to 2 into 4 by a is 3. So, which is 8 by 3. Next one, x square by 36 plus y square by 16 is equal to 1. So, here a square is 36, b square is 16 and a square lies as the denominator value for x square. So, therefore, this is the standard equation of the form x square by a square plus y square by b square is equal to 1. Now, we need to find out c, which can be written as root of a square minus b square. So, c is root of 36 minus 16. So, c is root 20, or we can write this as 2 root 5. Now, let's write. So, a square is equal to 36 means we get a is equal to 6. B square is 16 means we get b is equal to 4. So, we have all a, b, c. So, first foci. So, it's an horizontal ellipse, which means the major axis is along x-axis. So, therefore, foci is plus or minus c, 0, which becomes plus or minus 2 root 5, 0. Next, we have vertices, which is plus or minus a, 0. So, plus or minus 6, 0. Next, we have major axis. Major axis is 2 times a, which is 12. Minor axis 2 times b, which is 8. Next, we have eccentricity c by a, which is 2 root 5 divided by 6, which becomes root 5 divided by 3. Next, we have length of latus rectum. So which is 2b square by a, which is equal to 2 into 16 divided by 6. 2 1s are 2 3s are, which is 16 by 3 units. So the next type of question is, we are supposed to find the equation of an ellipse which satisfies the given condition. The first one is vertices and foci. So observing the coordinates, we can clearly see vertices lies along the x-axis. So therefore here, major axis is along x-axis. So when the major axis is along x-axis, the standard equation will be of the form x square by a square, y square by b square is equal to 1. Now observing the vertices here, the value of a can be taken as 5. Observing the focus, the value of c can be taken as 4. Now the standard equation of an ellipse will be of the form x square by a square plus y square by b square is equal to 1. We need b. So we know the relation a square is equal to b square plus c square. So if we want b square, then it is a square minus c square. So a square is 25, c square is 16. So b square value is 9. So therefore, the standard equation becomes x square by a square, which is 25, plus y square by 9 is equal to 1. So this is the required equation of a given ellipse. Next one, ends of the major axis is 0, plus or minus root 5. Ends of the minor axis is plus or minus 1, 0. Now, major axis, here it is along the y-axis. So that's why the coordinates is in the form of 0, a and 0, minus a. And minor axis, since it is along x-axis, so therefore it is of the form plus or minus 1, 0. So whatever it is, they have given us a and they have given us b. So major axis is along y-axis. So therefore the standard equation takes the form x square by b square, y square by a square is equal to 1. Now from this we have the value of b as 1. So it is 1 square plus y square by value of a is root 5. Root 5 whole square is equal to 1, or we can write this as x square by 1 plus y square by 5 is equal to 1. So this is the required equation of an ellipse. Next one, length of the major axis is 20. Foci is plus or minus 5. So when I say length of the major axis, 2a is given, which is 20. So this implies a is equal to 10. And when you observe the foci, 0, plus or minus 5 is a coordinate on the y-axis. So when foci is on the y-axis, that means the given axis or an ellipse is of the form vertical. So that's why the major axis is y-axis. So major axis lies along y-axis. Therefore, the standard equation becomes x square by b square plus y square by a square is equal to 1. Now we have value of a. So when foci is given, we have c, which is 5. Now to find b square, this can be written as a square minus c square. So the value of a is 10. So 10 square is 100. And c is 5. So c square is 25. So we get b square is equal to 75. So thus the equation becomes x square by 75 plus y square by 100 is equal to 1. Next one we have b is equal to 3, c is equal to 4, center at the origin, foci on the x-axis. So when foci is on the x-axis, the standard equation is of the form x square by a square, y square by b square is equal to 1. Now we have b, so we can find b square. We need a. So we know the relation a square is equal to b square plus c square. So this becomes 3 square, 9, 4 square 16. So a square is equal to 25. So therefore this is x square by 25 plus y square by 9 is equal to 1. The next one, length of minor axis is 16, foci is 0, plus or minus 6. So when I say length of minor axis, 2b is equal to 16, so b is equal to 8. When foci is given, c is equal to 6. But look at the foci, it is on the y-axis. So therefore, the standard equation takes the form of x square by b square plus y square by a square is equal to 1. Now to find a square, it is b square plus c square. So 8 square is 64, 6 square is 36. So a square becomes 100. So this implies the equation is x square by 8 square is 64. So therefore 64 plus y square by 100 is equal to 1. So this is the required equation of an ellipse. So in today's session, we have learnt about the ellipse and its properties. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.